Hey, what's up everybody? It's Mr. Boylan. We're going to work through some quick guided practice problems. Before we do though, I cannot emphasize enough how important it is in these types of problems to list out the things that you are given in the problem to identify the gas law that you're going to use. The math in these types of problems is very basic math, but oftentimes where students get lost is trying to identify what information they need to use and which gas law is the appropriate gas law. So I'm going to work through a couple of problems. The first one is going to be pretty explicit and fairly slow, but then I'll sort of pick up the pace for future problems. Okay, so let's take a look at problem number 1. It says a sample of oxygen gas has a volume of 150 milliliters when its pressure is 0.947 atmospheres. What will the volume of the gas be at a pressure of 0.987 atmospheres? So again, I'm just going to make a quick list of what I'm provided with in the problem. My initial volume, or V1, is 150 milliliters. My initial pressure, or P1, is 0.947 atmospheres. I'm looking for a new volume, or V2, at this new pressure, or P2, which is 0.987 atmospheres. Okay, so you'll always have a formula chart in which to pull this information from, but we have got just volume and pressure conditions that we're concerned about. The sample of oxygen gas is not changing. The amount of oxygen gas is not changing, and the temperature is staying the same. This is a classic Boyle's law calculation. So Boyle's law for changing conditions like this is initial pressure times initial volume is equal to your final pressure times the final volume. Now it's simply a matter of plugging the variables into the formula using algebra and solving. My initial pressure value was 0.947 atmospheres. My initial volume was 150 milliliters. I set that equal to my final pressure of 0.987 atmospheres. And I multiply that by my final volume, which is unknown at this time, so I'll use the variable x. Now, before you do any math in these types of problems, I think it's really important to think about what condition has changed and what do you expect your answer to be before you actually solve it. Again, it comes back to understanding the relationship between the variables. And if you can do that, you'll be more successful than simply plugging in the numbers and chugging. It gives you an idea of whether the numbers that you're calculating are actually correct. So Boyle's law has an inverse relationship between the two variables. As the pressure increases in this example here, I should expect a decrease in my volume. So when we solve this, we're looking for a decrease in my volume from 150 milliliters. Now that we set it up, we're going to use some quick algebra to solve here. I need to divide each side by 0.987 atmospheres, which will cancel out the pressure on the right-hand side. But I need to divide my left-hand side by that same value. I'm going to use my calculator here to finish off 0.947 times 150 divided by 0.987. As I think about my final answer, notice units of atmospheres have canceled out. I'll be left with a unit of milliliters. My answer of 144 milliliters, when rounded to 3 significant figures, makes sense. I expected a decrease in volume because my pressure increased. Again, don't forget sig figs, don't forget correct units, and don't forget on the free response to show your work.